Okay, today I am going to be building myself a little Tesla style pack out of these 18650 batteries. I've got these four Samsung 18650s. These were my original batteries. They came out of the first laptop that I harvested. It was in fact my very first laptop I ever owned, and I bought that around 2004, and it had these four batteries in it. So I'm going to build myself an auxiliary battery. You have probably seen I've had this for a while. I originally built my auxiliary battery out of this, which is kind of a good idea, but it's very, very unsafe. So the reason I have an auxiliary battery, in fact I have two, is to run things like this nice little meter here that requires its own little battery supply. So the reason I'm using these four whole batteries, which is kind of overkill because two would do it, and I could build two separate auxiliary batteries, but the reason I'm using these, or all four of these, for one auxiliary battery is the fact that they are old and they are no longer anywhere near the capacity they originally were. These should have been about 2200 milliamp hours from the factory. The last time I cycled these, which was not too long ago, they all came out to be between 14 and 1500 milliamp hours per cell. So they've lost a lot of capacity. So they're really no good except to just put in, use for something like this. You wouldn't want to put these in the big Tesla style pack that I'm getting ready to build eventually here. So these work perfect for this. So I'm going to use these handy little, these are all individual little holders that I've put four of them together, and I need 8 of them all together. So what I'm simply going to do is put the first cell in there, positive up. The next one is going to be directly the opposite. Okay, I've got the first one on, positive, negative. So let's put the bottom on. They go on pretty easily. So what I'm going to do, this is going to be my positive lead, and then on the back, on the other side, I'm going to put a fuse here, and I've got this handy little fuse wire. I'm using the 5 amp fuse, so I'm going to solder a fuse right there. Then turn it back over and solder another 5 amp fuse wire right there. Turn it back over and do one more, battery to battery, and then this will be my negative out. So that way everything is protected. It's doing exactly the same thing as this would. It would be in series, the exact same way. But with this, there is no fuse anywhere. I've got a fuse holder here, and that's great, but that does absolutely nothing between each battery. And that's what I want, because if this battery here decides it's going to short out, you know what's going to happen? All its little friends are going to start picking on it and causing a problem. Even though it's in series, it's not in parallel, but it's in series. So maybe it wouldn't be like that, but I'm going to do it anyway. I'm going to go ahead and put 5 amp fuses. That way if something does go wrong, that fuse is going to break and then the battery's dead. Well, it's not dead, but it no longer is going to function, and that battery that went bad is now cut out of the circuit. So anyway, that's how I'm going to do it. So I already built one of these yesterday. I built a 3S pack, a little 12 volt pack. Let's go have a look at that now. So after putting together this little 12 volt 3S pack yesterday, it was completely dead when I put it all together. I put it on the solar charge controller here and put the solar panels up in the window here, just like you see right now. But they're not doing very good, unfortunately. It's only up, it was at 9 volts when it was completely dead yesterday. It's only up to 10.9. So the reason I'm not getting hardly any charge out of these solar panels is because they're in my window. And it's cloudy and rainy out here today. So it really has almost no chance to get any sun at all. There is going to be a little bit of blue sky between rain showers today, just like yesterday. And right at this very moment, the panels are getting pretty good sun. So I really have absolutely nothing to lose by trying to charge up this little 3S pack today. And as you can see, it's actually came up quite a bit in the last few minutes, and now it's now at 11.1, teetering with 2 volts. So that's pretty good. It only has to come up to 12 volts is what I've got this thing to shut off at. And this being only a little 3-cell pack, 12 volt pack, it shouldn't take very long to charge this up. Certainly if the panels were outside sitting on the pickup truck in the direct sunlight, that little 3S pack would be charged up and nothing flat. But rain showers are kind of off and on, and my solar panels are not waterproofed yet. So we'll see if we can get this thing to charge up today.